Hello my dear PU2 champions, welcome back to the channel. So as you know, we have covered the quick revision, we have done 1 marker. Now it's time to get started on the questions coming in the category of 2 marker, 3 marker and 5 marker. Okay, so I've taken total of most important 15 questions. If you solve all these problems, I'm very much sure that you'll get out in your matrices chapter from whether it is 1 marker, 2 marker, 3 marker, 5 marker, all. Why I can say that with so much with surety is because it's a very simple chapter. When you see the questions, you'll get to know. Okay, and all the problems that all these problems that I've taken over here are from the question bank. Okay, starting with such an outline. So if you see, I have distributed question 1 to 7 in the 2 marker, question number 8 to 12 in 3 marker, and 13 to 15 the last 3 questions in 5 marker. I hope this is very much clear. Okay, let's start now. 2 marker question. Okay, so total I've taken here 7 problems. Let's see all of them one by one. Question number 1 is if x times of 2 3 is a column matrix, y times of minus 1 1 is a column matrix, again equals to 10 5. Find the value of x and y. Okay, we can do that. We'll get 2 equations over here. 2x minus y equals to 10. Over here we get 3x plus y equals to 5. Add these two, gets cancelled. You have 5x equals to 15, which means x value is 3. X value is 3. Clear? X value is 3. Okay. For the last one, for the y value, use from here. Y equals to 5 minus 3x. So y equals to 5 minus 3 times of 3, 5 minus 9, that is y value, and y comes out as minus 4. So x value is 3 and y value is minus 4. That's the answer for the first question in the 2 marker category. Okay, moving on to the question number 2. Excuse me. Yeah, question number 2. First one is clear, right? First one is clear. Yeah. Question number 2, please check. Find the matrix X if y is given, and they also have given you 2x plus y. Now of course, when we're dealing with addition and subtraction in matrices, we must have the conformable matrices, right? Basically the same order matrix would be there. So we have 2 cross 2 over here, and we have 2 cross 2 over here as well. We can write here 2x equals to the matrix which is given to us is 1 0 minus 3 2 minus the matrix y. I'm moving this y on this side. Okay, let's substitute the value of y now. Substitute the value of y, we get 1 0 minus 3 2, this is 0, okay, minus 3 2 1 4. Subtract now. 1 minus 3 is minus 2, minus 2 minus 3 minus 1 is minus 4, and again minus 2. This is my 2x matrix. I'm looking for the matrix x. So it will become what? It will become minus 1, minus 1, minus 2 and minus 1. It's also a 2 cross 2 matrix. Okay, very simple. Very simple problem. 2 marker. Have a look. So of course this year's question bank has not come yet. So I've referred the previous year's question bank basically for the year of 2025. Once they release this year, we can use those in the questions. Okay, let's start. Question number 3. In this they have given us 4 variables A, B, C, D. And we can compare each of these corresponding elements to get 4 equations as well, right? When can we say the given 2 matrices are equal if the corresponding elements are equal? See over here, A minus B equals to minus 1. Okay, we also have 2A plus C equals to 5, 2A minus B equals to 0. Okay, and we have 3C plus D equals to 13. Subtract over here. Subtraction. This will be cancelled. You have here C plus B is 5. C plus B is 5. Okay. All right. So we'll make use of this equation. We'll make use of this equations. So we have A minus B equals to minus 1. Add them. Cancels. We get here C plus A, so A plus C equals to 4. I'm going to use this equation where my equation number 1 and this equation over here. clearly, right? Because we have 2a plus c as 5 and a plus c as 4. 2a plus c as 5 and a plus c as 4. Subtract them. A equals to 5 minus 4 is 1. So value of a is now known to us. A is equals to 5 minus 4, which is 1. Clear? Alright. So a is 1. Now we'll find the value of c from here. C will come out as a. Please check here. If a is 1, c will be 4 minus 1. So c is 3. C is 3. Okay. And from here we can get, please check, from this equation we get b equals to twice of a. It means b is twice of 1. So b is 2. And d, from here we can see 3c plus d is 13. So d will become 13 minus 3c. So 13 minus 3 into 3. D is coming out as 4. So your value of a, b, c, d is 1, 2, 3, 4. 1, 2, 3, 4 is the value of a, b, c, d. Clear? Okay. Let's move on now. Question number 4. This is clear, right? This is clear over here. Yeah. If you have a faster way, same result, if you are getting accurate result, then you can use that as well. But one of the ways I have taken on the stream. Okay. Question number 4. AB is, we are asking us to find AB. The product, right? Let's do it. So we'll go row to column. 6 into 2 is 12. 9 7s are 63. So 12 plus 63. Same way, 6 into 6 is 36. 9 9s are 81. Okay. 6 into 0 is 0. And 9 8s are 72. That's my first row of the product AB, matrix AB. This time I'll go with the second row. 2 times of 2 is 4. 3 7s are 21. 2 times 6 is 12. 3 9s are 27. 0 and 24. My answer for AB is coming as 75, 117, 72, 25, 39 and 24. That's the product. The product of given matrix. Try to solve this with patient. Okay, be a little patient in solving this question. Otherwise, you'll end up making silly mistakes. And this questions usually comes in the 5 marker category. Okay, 3 marker, 5 marker, they ask this question. If you actually take your time to do this, you'll get those 5 marks correct. Okay. Question number 5 now. Simplify. Basically, we are supposed to multiply a scalar quantity to the entire matrix. In this case, we have cos, we have sine. Multiply this, we get cos square theta. Cos into sine is cos theta sine theta. Cos minus sine will have minus cos theta sine theta, and over here we'll have again cos square theta. Right? That's my first product. Okay, scalar multiplication. Sine with this will have here sine square theta minus sine theta cos theta. We have sine cos theta, and we have sine square theta. Add them. Add them. Sine square plus cos square is 1. Cos sine minus sine cos is 0. Cos sine, sine cos is 0. Cos square plus sine square is again 1. We're getting the answer as identity matrix of the order 2. Okay. Question number 5 is very simple question. It's over. Question number 6 now. Find P inverse if it exists given P value as 10 minus 2 minus 5 1. Okay. So how do you find check for whether the inverse exists or not? We check for the non-singularity, right? And we check it like this: determinant of P should be not equal to 0. Then only we'll say that inverse exists. Let's find determinant first. 10 into 1 is 10, minus of minus 2 into minus 5. Okay, we get here 0. It means P inverse does not exist. P inverse does not exist. Correct? P inverse does not exist because it is a singular matrix. I'm getting the determinant value as 0. Okay, 6 is done. Question number 7 now. If A is 3 root 3 2 4 2 0, B is something, verify the conditions. This you can do, this I will solve. Part 2, this will be your homework. Okay, comment as verified. After solving this question, no, let me know whether it is verified or not. I'll help you solve the second part. Okay, first add the a plus b. Add a plus b. What do you get if you add them? You get 5 here. You get minus 1 plus root 3. Okay, and you get over here 4, 5, 4, 4. That's a plus b. I'm looking for transpose, so do the transpose. A plus b transpose will be given by, check, 5 minus 1 plus root 3, and this will come here 4. This row becomes column, right? And over here we'll have 5, 4 and 4. The row becomes column. That's my a plus b transpose. This is the LHS side, right? This is the LHS side of the part 2. Let's find the RHS side. Find a in transpose first. Find a transpose first. Let's try. So I get a transpose as 3 root 3 2 4 2 0, making row as column. B transpose will be what? 2 minus 1 2 and 1 2 and 4. Now you add these two. Add these two. You end up with 5 5 minus 1 plus root 3, and this will be 2 plus 2 is 4, 4 and 4. Please check. Same thing. 4 4 4 5 5 minus 1 plus root 3 minus 1 plus root 3. So whether you take LHS or RHS, they comes the same thing. And if you all remember, that's the property of, I've taught you the property of the transpose already. This thing was covered, right? A plus B transpose is A transpose plus B transpose. Just verifying it over here with help of an example. Okay, 7th is done. Now we have completed our questions from 2 marker. We're going to move on to 3 marker category. Let's see question number 8, which will be from 3 marker. This is clear. Okay, 3 marker category. Let's solve this question. Again, the similar problem, you have to solve it. This is your homework. Comment verified. Okay, first one I will solve for you. First one I will solve. First find A transpose. We'll get cos and sine will come down. This will go here, minus sine alpha, cos alpha. Okay, this is my A transpose. Multiply these two. A transpose times A. From here row, from there column. Cos into cos is cos square alpha. Minus sine into minus sine will become plus sine square alpha. This is the first row, first column. Next go first row, second column. Cos sine. You'll have cos alpha, sine alpha, and then you'll have minus sine cos. You'll have minus sine alpha, cos alpha. You all know this is 0. This is 1, right? 0 and 1, you'll get this also as 0. This also as 1. Your answer will come as A transpose A will be equal to 1 0 0 1. So entry matrix of the order 2 again. Question number 8 is again done. This itself is property over here. This itself is a property over here. A transpose A is always equal to the entry matrix if A is a square matrix. Okay, done. Clearly, okay, let's move on. Question number 9. If A and B are symmetric matrices of the same order, then so that AB is symmetric if and only if AB equals to BA. First understand this. A and B are symmetric means what? A transpose is A, B transpose is B. That's the meaning of symmetric matrix. Okay, of the same order, right? I'm looking for AB. Let's call this to be matrix X. It should be equal to X, right? Basically AB. Then only I can call this to be symmetric. Either XT is X or ABT is AB. Then only we can call this to be symmetric in nature. Let's try this now. AB transpose is nothing but, we know the property. Which property is this? Reversal law. I get B transpose first. In the case of product, the second matrix comes out as first. This will be B. This will be A. but I should get this as AB, right? I'm getting here as BA. Only true if it is equal to AB. So basically the matrix AB, the product of the matrix A and B will be symmetric only if I have BA equals to AB, right? Got it? So it's proven now. Proven now. Please check. Question number 10. If A and B are invertible matrices of the same order, then prove that AB inverse is equals to B inverse A inverse. This is also a property. This also is a property. Let's see. So we'll use this understanding. X times of X inverse is equals to I. X times of X inverse is equals to I. Let's write X as AB. This as AB inverse equals to I. Equals to I, right? Yeah. This is I. Now multiply A inverse on both sides. I can do that. I can multiply the same matrix on both sides. So A inverse A will become what? I. IB. AB inverse. This will be simply A inverse. This time we multiply with B inverse. So I get here B inverse. This will become simply B. I have over here AB inverse. This will be B inverse A inverse. So what I get? Again I times of AB inverse equals to B inverse A inverse. Last step. Remove Y from here. You don't need to write I. I'm getting this equals to B inverse A inverse. Please check. B inverse A inverse. Excuse me. Yeah. B inverse A inverse. So this is what we're looking to prove, and we got it. Question number 10 is over. Okay. Moving to question number 11 now. Prove that any of the for any square matrix A with real number entries, A plus A transpose is symmetric and A minus A transpose is q-symmetric. Okay. So let me take this as X equals to A plus A transpose. Let's do one thing. Take X transpose, you get A plus A transpose the transpose. You'll end up with A transpose plus A. We all know matrix addition is commutative in nature. Matrix addition is commutative in nature. So I can write this as A plus A transpose. This is nothing but the matrix X. Okay. So I'm getting this as X transpose equals to X. It means X is symmetric. What's the X over here? A plus A transpose. I've proven that A plus A transpose is symmetric in nature. Let's go ahead and prove the other one. Take Y as A minus A transpose. Again, take this Y transpose equals to A minus A transpose transpose. A transpose minus A transpose transpose. How much is this? A transpose minus A. Take minus sign common, you get here A minus A transpose minus Y. This is Y, right? So I'm getting here Y transpose is minus Y. It means Y is skew-symmetric matrix. Y is skew-symmetric matrix. So what we have proven over here? We have proved that A plus A transpose is symmetric in nature and A minus A transpose is skew-symmetric in nature provided A is any square matrix. Provided A is any square matrix. Have a look. Clear? Okay. Now we'll move on to the last question of the 3 marker category. Then we'll start the 5 marker. Okay. Let's start the question number 12. Prove inverse of a square matrix if it exists is unique in nature. I need to prove that for any given square matrix, if there is an inverse, it will be always unique. Means for any matrix you will have only one inverse existing in nature if it exists, if it is a non-singular matrix, of course. Okay. So I'm gonna make a assumption over here. That is that for matrix A we have two inverse that exist. B and C are inverse. B and C are inverse. Basically I'm trying to say that in the beginning itself I will assume that there are two inverse, B and C, both of them are inverse, and if I can prove somehow that B and C are equal, what happens there? It means they become unique, they become single. So we're going to prove that B and C are actually not two different matrix, that's the same matrix, hence unique. I hope you got it. Starting from the assumption that A will have two inverse B and C, and later we'll prove that it is actually same. Okay, how do you define inverse? AB equals to BA equals to I for B to be inverse of A, and also AC equals to CA equals to I when C is the inverse of A. When B is inverse of A, I have AB BA equals to I, and when C is inverse of A, I have AC CA equals to I. Okay, let me take this multiplication as BAC. I'm taking the product of all three matrices in that order, BAC. I'll club B outside and AC together. What is AC? AC is same as I, means B times of I, which is what? B. Equation number 1. So I prove that BAC is equals to matrix B. Continue. BAC this time, but club BA together. What is BA? BA same as I. So I times of C, what it means? It is equal to C. Equation number 2. So basically I'm getting what? From equation 1 and 2, I'm getting BAC equals to C and B. It means what? B and C are same, equal. Therefore, inverse is always unique if it exists. Therefore, inverse is always unique if it at all exists. Okay, this was the last question from the 3 marker. Now we'll move on to 5 marker questions. Okay, 5 marker question. Here you go. A square minus 5a plus 6i value we need to find out. I have already found a square value. I'll show you. I'm going here. A square is nothing but a into a, row to column. 2 into 2 is 4, 0 into 2 is gone, 1 into 1 is 1, 4 plus 1 is 5, 2 0 is gone, 0 1 is gone, 1 into minus 1 is minus 1, 2 1 is 2, 0 3 is gone, 0. I get 2. Likewise, do the multiplication with second row and third row to the first, second and third columns. You get the answer as a square equals to 5 minus 1 2, 9 minus 2 5, and 0 minus 1 and minus 2. For 5a, what we get? Multiply 5 to the matrix A, 10 0 5, 10 5 and 15, 10 minus 5 minus 5 and 0. I get 5a also. 6i will be what? 6i will be diagonal matrix with value of diagonal as 6. Okay, super. Now I'm looking for this condition: a square minus 5a plus 6i. Difference of these two, 5 minus 10 is minus 5 plus 6 is 1. Here 5 minus 10 is minus 5 plus 6 is 1. Minus 1 is 0 is minus 1. So I get minus 1. 2 minus 5 is minus 3. Okay, 9 minus 10 is minus 1. Minus 2 plus 5, minus 2 minus 5 is minus 7. Plus 6 will become minus 1. 5 minus 15 is minus 10. We have 0 minus 5 is minus 5. We have minus 1 minus 5 is plus 4. Minus of minus 5 will become plus 4, right? Minus 2 plus minus 0 is minus 2 plus 6 is 4. So my answer for a square minus 5a plus 6i is 1 minus 1 minus 3 minus 1 minus 1 minus 10 minus 5 minus 5 4 and 4. 13 is also over. Okay, all right. So this is clear, right? 13 is clear, no problem. 13 is very simple. Please check. A square you find first, 5a, 6i. Subtract the 5a from here and add 6i to it. You get the answer as this matrix. 3 cross 3 order. Okay. Moving on to question number 14 now. Okay. So I found AC already. I'll show you how I find this. Row to column for the first element. 0 into 2 is gone. 6 minus 2 is minus 12. 7 into 3 is 21. 21 minus 12 is 9. Next is what? 0. Next is minus 6 into 2 is minus 12. 0 and 24. So this is plus 12. We get 7 into 2 is 14. Plus 16 and 0. 14 plus 16 is what? 30. 14 plus 16 is 30. That's my AC. Same way you can get BC as well. From here to here, row to column, 0 is gone, minus 2 plus 3. Answer is 1. 2 and 6 is 8, 1 into 2 is 2, and minus 4 is minus 2. A plus B will be what? We are looking for A plus B times of C, right? Let's find A plus B first. You add this 0, 7, 8, minus 5, 0 and 10, 8, minus 6 and 0. Okay, that's my A plus B. Next is what? A plus B times of C. Next is this. So go like this. 0, minus 14 and 24. So we get here 10. Next you go second row. Minus 5. So minus 10 and plus 30. That is 20. Next the third row. 8 into 2 is 14. Plus 16 is. So 8 into 2 is 16 actually. Plus 2 is 28. 28. I'm getting the A plus B times of C as 10, 20 and 28. 10, 20 and 28. Okay. Now let's add these two. Let's add AC plus BC. This is a property, right? This is the distribution over addition. Distribution of C over addition, right? AC plus BC. 9 plus 1 is 10. 12 plus 8 is 20. And 30 minus 2 is 28. Check carefully, they are both equal. Hence proved, hence verified. Hence verified. Question number 14 is also over. Hence verified. Clear? Clear? Very simple. Okay. The last question is exact same, but in this case we have 2 cross 2 matrix to deal with. Okay. Looking to find AC, BC, A plus B times of C, and then verify this. How do you find AC? Please check. A to C. You have 1 into 1 is 1, 2 into 2 is 4, so 4 plus 1 is 5. 1 into 1 is 1, 6. So 7. 2 into 1 is 2, and 1 into 2 is again 2, so 4. 2 into 1, 1 into 3, so 5. That's my AC. Same way you can find BC as well. Okay, find BC and also find A plus B. Find A plus B. Find A plus B, and then later find A plus B times of C, right? And then compare the sum of these two is equal to A plus B times of C or not. This is again distribution of multiplication over addition. This is what? Distribution of multiplication of C over addition A plus B. Okay, please check. Clear? Simple question. Had fun. This is the end of the session then. So we have completed top 15 question from 2 marker, 3 marker, 5 marker for your chapter matrices. Now you might feel they are very easy. Yes, they are. They are actually very easy. So don't have to worry about that. So if this questions comes in examination in your midterm, you have to get out of out. Okay, you have to get out of out. Just remember the properties of matrices. 1 marker, do not make silly mistakes. If you need something from me, if I missed something in your chapter, let me know in the comment section. This is it for now. I'll see you again very soon. Till then, take care. Bye bye.